अब हम इस लेक्चर में further we will discuss some further types of curves, and we will see some examples about Jordan curves, simple curves, and closed curves. Next one, the fifth one is the polygonal line. A polygonal line is the collection of lines, some pieces of lines like this. So at this point we have problem of smoothness. We have two different tangents at this point. So this point is non-smooth. This point is also not smooth. But here this part is a line, this part is also a line, this part is a line. So we have a polygonal line. For example, we have this example of a gamma or z of t. This is gamma of t, and t is from 0 to 2 defined in this way. First part is from 0 to 2. From 0 to 1 we travel along this path, x plus iota x. So we plot this path. At 0, gamma of 0 or z of 0 is 0 plus iota 0, and this is the origin. 0 plus iota 0. This point maps to this point. And moving in this direction, when we have x or t, okay, sorry, this is t, this one is x, okay, replace this by variable x, okay, this is x. You can choose any name for the parameter. It can be t, it can be x, anything. And when you have this value of x is 1 by 2, so z of 1 by 2 is 1 by 2 plus iota. 1 by 2 is this point, and when you have it is equals to 1, you have 1 plus iota 1 is this value. So you get this line. For this part you travel along this line, and at 1 z of 1 is 1 plus iota, the same point here, 1 plus iota. And then when x is equals to 1 half, means 3 by 2, you have x 3 by 2 plus iota. So x 3 by 2, this is 1, x is 1, and this is 3 by 2, 1.5. But y coordinate is iota, same iota. So you are here. So 2, for x is equal to 2, z of 2 is equals to 2 plus iota, means x is changing, whereas y coordinate remains 1. So you have this 2. So combining this, you plot this part. So this piecewise function, which is continuous function for all values of x from 0 to 2, we have this map, and this map is the polygonal line. It consists of two lines joined at a point. ठीक है, तो हमारे पास polygonal lines क्या होगी, ये 2 या 3, यानी इसके पार्ट्स जो हैं वो लाइंस का कलेक्शन होंगे, जॉइंट होंगे किसी पॉइंट पर. तो फॉर एग्जांपल ये आपके पास एक पोलिगोनल लाइन है. इसको ओरिएंटेशन आप ये ऐसे दे सकते हैं कि ये ट्रैवलिंग इस डायरेक्शन में हो रही है. ठीक है, अगेन ये ट्रैवलिंग हमारे लिए मैटर क्यों करती है कि हम पता जानते हैं कि ओरिएंटेशन का इंटेग्रल अलोंग गैमा और माइनस गैमा ये रिवर्स इन साइन होंगे, सेम वैल्यू बट साइन ऑपोजिट होगा. तो ये पॉलीगोनल लाइन थी. ठीक है, नेक्स्ट हम आगे देखते हैं फर्दर. ठीक है, फॉर एग्जाम्पल ये एक इक्वेशन है, z इज इक्वल्स टू ई आयोटा थीटा, थीटा ranges from 0 to 2 pi, okay, and we want to draw this function, this path. This can be written as z of theta or z of t. Theta is the parameter, and this is e iota theta, and it becomes cos theta plus iota sin theta. So here is the parameter theta from 0 to 2 pi. From 0 to 2 pi, this is theta, and this is complex plane. If you put value of theta equals to 0, you get gamma of 0 or z of 0, and this is a point cos 0 1 plus iota sin 0 0, means this is this point, this. Okay, and then if you take theta is equals to some pi by 2, which is here, you will get cos 90 0 plus iota sin 91, so you will reach here. And at the midway where theta is equals to pi, you will reach here, because this cos pi is minus 1 and sin pi is 0. You will reach here, and exactly at 3 pi by 2 you will reach here. And if you clearly see, if you rename it as some real variable t1 and it is t2, and if you square and sum it, you will get 1, means these two coordinates will satisfy this equation, showing that this is a unit circle. So this is a unit circle, and you are moving along this unit circle. If you increase the value of theta, you move in this direction, which is anti-clockwise. So this e iota theta is this curve, is this path, positively oriented, simple, and it is also a closed curve where you only allow points, 2 points 1 and 2 can join this, they meet, they not self intersect. So it's a simple and a closed Jordan curve. And here is this origin added to it. This origin plays the role of this center, and this one is the radius. So if you define this z of theta in this way, this z1 plus some r e iota theta, and theta moves from 0 to, let's say, 2 pi, then this will again be some circle centered at z1, centered at this z1, radius this r, and you move in this. So this is the path or parameterization for any positively oriented circle. Or if you place a negative sign over here, you will get a negatively oriented circle. You will move in this direction. This will be clockwise traveling on this curve. This will be negatively oriented curve. These curves will be necessary to understand contour integration. Now, what is a contour? This is the last path. We commonly name such paths as contour. Contour is something, a curve that is piecewise smooth. It means you have a curve, part of curve, some curve. Here you have some sharp edge, corner point. Here is this, and this curve have some sharp corners, but these corners are few and far. यानी कुछ ही कॉर्नर पॉइंट्स होंगे, फाइनाइटली मैनी आप समझ ले होंगे, और बाकी सब जगहों पर आपके पास एक यूनिक टेंजेंट एग्जिस्ट करेगा. तो ऐसे कर्व को मैं पीस वाइज स्मूथ कहूंगा कि बाकी सब जगह पर इनके ऊपर टेंजेंट एग्जिस्ट करें सिवाय इन चंद पॉइंट के, क्योंकि यहाँ दो डिफरेंट टेंजेंट्स आ रहे हैं. तो ऐसे कर्व को कॉम्प्लेक्स एनालिसिस में हम कंटूर का नाम देंगे. सो वी विल नेम दीज कर्व्स कंटूर्स विच आर पीस वाइज स्मूथ कर्व्स. सम पीसेस जो होंगे वो क्या होंगे, स्मूथ होंगे. अब उसकी रीजन ये है कि हमने फर्स्ट प्रॉपर्टी जो डिस्क्राइब की थी कंटूर इंटीग्रेशन की, वो हमने कहा था कि एक बड़ा कर्व जो कि टोटली स्मूथ नहीं है, हम उसके क्या करेंगे, उसे पीस वाइज स्मूथ बनाएंगे और हर एक पार्ट के अलोंग हम उसकी क्या करेंगे, इंटीग्रेशन करेंगे, उसको सम कर देंगे और वो पॉइंट्स जहां पर वो स्मूथ नहीं है उसको हम निग्लेक्ट कर देंगे क्योंकि निग्लिजिबल कंट्रीब्यूशन होगी उस पॉइंट की. तो पूरा हमारे पास क्या आ जाएगा, पूरा कंटूर इंटीग्रल आ जाएगा अलोंग दिस होल पाथ. ठीक है, यहां से आगे हम कुछ एग्जांपल्स कंस्ट्रक्ट करेंगे सॉलिड. ओके.